Okay, so this is from Mr. Smith's class, right? Everyone say hello first period. Hello. Okay, third period, this is for you. But now remember, we're bringing in stuff. Now, guys, we have to review some words here. And this is not on the notes. We're going to make sure that we're there. You guys, you remember what a rational function is, or a rational expression, okay? What is a rational expression? We'll just say function. We'll put a y in front of it. And this was from first semester review right before finals. So you can either go f of x or y, but when are we going to have a rational expression or a rational function? This is why we're reviewing this. Okay. It's a fraction. Okay. No, it really is. It's just a fraction, but it's a polynomial over a polynomial. Okay. So basically, think of it like this. It's a polynomial function over a polynomial function. So that means you're going to have variables top and bottom. And so we have to treat things a little bit differently.
I need Brittany, Elia, and Abby to go to Mrs. Timmons.
All right, sounds great. All right, so with this one, guys, here's a quick example of something like this that you would have. You could something like x squared minus 4 over x cubed plus 8. So that's basically the idea. That would be a rational expression. Remember, this is some of your favorite things. How about knowing what the domain of the function would be? Or knowing when it was valid and it worked or didn't work. It's all based off of those steps and really basically how the graph is going to look. So we're just working with functions with those. Now, we're going to do these a little bit out of order when we're doing this, but I'm okay with that for my own self here. So understand that this is Mrs. Napier and Mr. Smith's order. I'm going to do it in a different order because it makes a little bit more sense to me. There's not enough room for a real huge visual example. So I'm going to do a lot of the math, and then the example down below is going to be really huge that we understand. So the first thing that I want you to remember is when you're working with any of these, we actually go through a process like, what do I find first? What do I find second? What do I find third? And it steps you through doing the graph. So we're going to do this. I'm going to try to, Lord be with me on this, I'm going to try to do different colors. And if I don't go different colors, kind of like I just get going and I forget I put everything one color and it won't make as much sense. So I'm trying to even do this with very much colorful light to make more sense to you guys. So the very first thing we're going to start with is a vertical asymptote. Okay, guys, what is a vertical asymptote again? It's a line that goes which way? Vertically, that you can't what? You can't touch. Remember, we used those a lot when we were graphing our parent functions a while back. So those were huge that we need to know. So a vertical asymptote, that's really what it is. So remember, how do I find this? And this will always be your first thing to do. Okay, so do your vertical asymptote first. Are you guys with me on that? So do the vertical asymptote. Just remember, it's where you find this, it's just the values that occur. I might enlarge that a little bit and then shrink it back down. When the denominator equals 0 and has no common factor. I'll let you guys write that down, then I'll show you an example of this. And by the way, you just heard the word factor, right? There's going to be a lot of factors you have to be able to do. So if you can't factor, these are one of those disastrous lessons. So you might want to make sure you know what we're doing with this. So ask questions as we go. Here's what I mean by this. What if I took the time and I had a rational function, and I'm just going to use this one right here. What if I got f of x is equal to, there you guys go. F of x is equal to something, and when it's factored out, it looks like this. X plus 2 times the quantity x minus 3 over x minus 3 times the quantity x plus 4. So basically, I had two polynomials. I graphed them out. All right, when you look at this, When is the denominator of that function equal to 0? When is the denominator of that function equal to 0? Isn't that when you go x minus 3 is equal to 0, x plus 4 is equal to 0? I'm not trying to be like flippant, but isn't that when it happens? Right? And so you get two answers. You get the fact that x would equal 0 at 3, and you got x would equal 0 at negative 4. But remember, it says values that occur when the denominator is equal to 0 and no common factor. Well, do you guys see that there's a common factor in the numerator and denominator? Okay, that would be your x minus 3. That is not where I'm going to have a vertical asymptote. Guess where my vertical asymptote would be for this one? It'd be at the line x equals negative 4. Because the x minus 3, that's a repeat. That's a common factor. Basically, that gets removed. I reduce it out, right? And so that means I'm totally okay. I'd have a vertical asymptote at the line x equals negative 4. So that would be your VA. All right, so obviously initial we're going to use for this. Your vertical asymptote would be x equals negative 4. So if I had a graph, and I'm going to put this off to the side, guys. I don't know if I'd put space on this or just watch right now. You would sit there and have your x, y-axis, and the first thing you should have graphed would be right away, there's that negative 4. That would be your vertical asymptote. Remember doing that last year a little bit more now? Hopefully. All right, great. So that's what you do first. Now, what would you do next? You'd actually find the hole next. So I do this first, always, first process, and then I'm going to change colors because I said I was going to. Let's go green. So this would be your actual second step that I would do because it's so closely related to the first one. All right, a hole is basically where the graph is going. It doesn't work for that number only, and it keeps going. And it's an actual ordered pair, okay? So understand it's an ordered pair that it doesn't work. So literally, you could like get your graph drawn. There's going to be an open circle, and then it just keeps on going through it. Your calculators will not show that. Okay, so just heads up, your calculator will not show that. However, if you go second table, it will actually show that there's an error there. And so it does give you, like, if you look at the table, like, oh yeah, something isn't supposed to work right there. And so know that calculator is not helpful. It will just give you a general idea of what the graph looks like, but it's not going to show you the little nuances like here's a hole or where did this come from. So kind of keep that in mind. So what is a hole first of all? So remember, it is an ordered pair. So it's going to be an ordered pair where you have factors that cancel out. You're going to see where we're going to be going in just a moment with this one. So it's an ordered pair where you have factors that cancel out. All right, so use that example I have real quick there up at the top here. Where did I have, where does it cancel out? What factor? What x equals 3? So this is actually your hole. Now a hole is an ordered pair. That just gives you the x value of the ordered pair. So really, I got to sit there and figure out what's the y. Well, this is where it's actually really easy. You can plug it into the very original function. A lot of times when we put in these rational functions, you could put it in right away into the very original one, or you can put it in your factored form. If you put it in your factored form, you can do it without the stuff that you canceled out. So basically, you could sit there and go, okay, I can put it into 3 plus 2 over 3 plus 4. What does that get me? 5 over what? 5 over 7. So that's where the hole would be on your graph. So the fact is, it just really, when you get a hole, you get the x comes from whatever is the repeated common factor in the numerator and denominator. But I have to plug it back into the function to find out what the y value is going to be. So it's an ordered pair when you do that. So does that make a little bit of sense? Does that recall what you guys did last year a little bit? So just remember, you have to really plug and chug it in to figure it out. So I have to plug the 3 in to come out. And I'm not going to plug it in. Now, here's the deal. I'm not going to plug it in with 3 minus 3, 3 minus 3, because then you're going to get 0 and it doesn't really help me much, right? But you can always do it, plug it back in. Pretty simple process. So that is going to be the next thing that you do. Now, Here's what I would do third, because I think it's a little bit easier to do. The thing I would do third is I would actually do the zeros third. And this is where it's a little bit different than what we're used to. All right, just give me about you here. Okay, what color should we go with? Let's go boring. Let's go gray. All right, so this is what you're going to do third, is find the zeros. Now, how do I find the zeros? This is very easy. It's when your numerator equals 0 after common factors are taken out. So it's when the numerator equals 0 after common factors are taken out. All right, my friends. So going back to our original function here. So I'm going to do it over here. We have our f of x. It would have been our x plus 2. If I took out my x minus 3, and we have those are out, and I have my x plus 4, what part of that function do I use to find what the 0 is? Numerator is what? Top or bottom? Top. You just have to set that equal to 0. That's all you have to do. So you're going to sit there and go, x plus 2 is equal to 0. X is going to equal what? Negative 2. So your value on this would be at negative 2, 0. So your 0, remember, zeros are ordered pairs. It's just that your y value is always what? 0. So that's a cool part. So this is where this 0 would be. So that would be your third thing you should do. So first of all, you find your vertical asymptotes, then you find your holes, then you find your 0. So think about what this graph up here is going to look like. First of all, let me go backwards here just a little bit. This is my bad graph that really is, like I said, if I had more time, I would have changed the notes so it would have been a little bit easier to see. All right, I know I have a 0 at negative 2, so let me put that right here. So I know I'm crossing here at negative 2. I have a hole at what ordered pair? 3 and 5/7 or something like that? Make sure I got my color change here. So whatever 3 and 5/7, something like here, there would be a hole. We're making that 5/7 just to make it easy on ourselves. So we have a hole there, but then I still can't do any graphs yet because I still have to figure out my horizontal asymptote. Now here's the problem. This one has a lot more scenarios. This is more the pain to learn and be able to work with. I think we're going to go back to red on this one because you have to know the rules. I wonder if you guys remember these from last year. Were you guys good at these last year? Well, that was a strong feel of emotion on that one. Okay. I could see why this is hard because there's so many steps. I just remember when I was trying to teach you guys when you were younger and we did more than like a 3-step problem, you all revolted on me. So I totally understand. All right. Horizontal asymptotes have 3 scenarios. Okay, guess what? 3 lines that are probably not enough room to do with it. Okay. They're actually not bad to do. But again, you have to know degrees. You have to be able to work with these so that they make sense. And I'm going to actually move on to a different function just so I can show you ways of solving for it. And then we can go back to this one if we have a little bit of time. All right, so what's the very first type of horizontal asymptote you can have? Okay, your very first one that you could have is going to be if you have y equals 0. So when y equals 0, isn't that the x-axis? Okay, that is one of your horizontal asymptotes that you can have. That happens when the following is the case. It's when the degree of the numerator is less than the degree of the polynomial in the denominator. Actually, I'm just going to, if I go DEN, does that make sense enough? If I abbreviate it, denim. No, we're not going to do that. All right, a denominator. We'll write it out. Denominator. We'll just do it like that. Now, degrees means you're going to have to be able to look at each of your numerator and denominator of your rational function as polynomials. So you know the degrees when you work with it. So let me give you an example of that. I think I can do a little bit more room here off to the side. What if you had a function that looked like this? F of x is equal to, let's go 3x squared plus 2x plus 9 all over, and I'm going to blow that up there a little bit, 7x to the 4th plus 3x minus 7. Which has the higher degree? The numerator or denominator? The bottom. So that automatically means, all right, I have an asymptote at y equals 0. Now here's the reason why. If I put large numbers into that, right, doesn't the denominator get really, really large? The top one would be kind of different. But the denominator gets larger and larger, and the top kind of stays put. Doesn't that get closer and closer to 0? So you're not going to cross it. So that's why it works that way. So there's a reason why on that. But all you have to do is look right here. Everything's going to be looking at the degrees. For the 3 reasons that we use, we're always going to be looking at the degrees. So in this case, 4 is obviously larger than 2, so the degree in the denominator is bigger than the degree in the numerator. So that's the first scenario. Then there's one that I like. There is no horizontal asymptote. It's wonderful. And that's when your degree, and I'm going to abbreviate that, of your numerator, shrink a little bit, is greater than the degree of the denominator. So that's the second scenario. So you might actually not have a horizontal asymptote. We like those, less things we have to worry about. So on this would be a case, just flip those over. What if I had something like, here's my function, and I had like 7x to the 4th minus 3x squared over, let's go our 3x squared plus 5x plus 1. Again, I'm looking at the leading coefficients. I'm looking at the degrees. Well, 4 is greater than 2, so the numerator this time is bigger than the denominator. No asymptote. There won't be one this time. Now, there's obviously, I have a third scenario here, but hopefully, now is this starting to jog memories back? Maybe slightly. You should be done. Memories coming back. This is about this time last year. You were graphing all the parent functions and you were starting to do all this stuff. Some of you are like, I tried to block out last year. I mean, you're supposed to learn. Just remember that. You're supposed to learn. All right. Because I always tell you have to remember geometry for the next 3 years. And I haven't lied to you yet on that. Have you guys been practicing for your ACT? Okay, that's better. All right, moving on. Some of you are like, I'm avoiding it. All right, now here's the next one. You have a time where you're actually going to have a different horizontal asymptote. And the horizontal asymptote is going to end up being a ratio. So it's just y equals a ratio. Now, where in the world does that ratio come from? It still comes from working with the degrees, and it's still working with our polynomials. But it's when you have the following scenario. When the degree of the numerator equals the degree of the denominator. So it's a different scenario than the other two. And it's not hard to do if you're really good at figuring out what your leading coefficients are. So a quick example of this would be a function where I have something like 7x cubed minus 6x over, let's say, 3x cubed plus, I don't know, let's just say 3. So I look at the degree for the numerator and denominator. They're exactly the what? They're exactly the same. So here's the cool part. If they're exactly the same, then all you have to do is literally pull out the coefficients. It's just going to be, the ratio is going to be 7 over 3. So for here, my horizontal asymptote for that problem is just y equals 7/3. But remember, make sure you do it for the problem. That's why I'm putting an arrow there, because that's really messy. But that's how you would do it. So if it's exactly the same, you just look at what the coefficients are. I'll let you guys write that down before we do our first gosh, we'll try. Aren't you so excited? I mean, just the joy is just coming out that you want to do these. I can just tell, especially Josh over here. Just like, please let me do a problem. Right, Josh? All right. So here's the thing you got to do, though, and this is where it's huge. You need to be able to know how to pick out a degree. Okay, you need to be able to see the degree of any polynomial when we're working with it. But here's the other thing you have to be really good at. You have to be able to factor completely. And like I said, if you're not good at factoring, it really comes back to start hurting you now. So we need to be able to factor completely on this one. All right, guys, help me make sure I do these in the right order. Okay, what color did I do the vertical asymptote in? You remember? Was that blue? Vertical asymptote was blue? Okay. All right, so here's what we're going to do. Today, it's basically you're just graphing these, okay? You're graphing these rational functions. So go in the order that we talked about. So the first thing you're going to do, though, is you're going to factor it. All right, when it's not factored, you've got to make sure you factor it completely. So just going off to the side, factor. So what does my numerator, guys, factor into? So you got 2x and x, okay. What are the signs inside? I always do the signs inside my parentheses before I do anything else. What are the signs inside your parentheses? So we got a plus minus, right? Okay, factors of 6. 3, 2, where are you going to put the 3? Where are you going to put the 2? I can't put the 2 first, right? So I can go 2x plus 3, and I got the quantity x minus 2. Remember, I can't put 2 and 2 together because that meant there was a greatest common factor. Can't do that. Always make sure your signs are correct. So in order to make sure you're doing this right, you're going to have to actually check to see you're factoring there. Remember, those of you who had me, I would say do the OI of FOIL, outside, inside, check. Outside's a negative 4x, inside's a positive 3x. Does that give me a negative x? For my middle term, yes, you're going to be fine. All right, what does x squared minus 4 factor into? X plus 2 and x minus 2. Very good. That's a difference of 2 squares. All right, so let's do the vertical asymptotes first. So remember, I would lightly just cross out your common factor. Okay, so just like, because you still need to see it and you still need to know it. But remember, when you're working with your vertical asymptote, it's just where your denominator is equal to 0 after you take the common factor out. So all you'd have to do is go x plus 2 is equal to 0. X is going to equal what? A negative 2. Remember, if you can do that in your head, that's okay. That's a pretty simple one to do. So I have a line at x equals negative 2. So go over to your graph and literally put in your vertical asymptote. All right, so everyone should make sure to put your vertical asymptote in. It's just good to do it as you go. And there's a reason why I'm changing the colors up on this on purpose. Okay, what color did I use? Let me look up here. What did we do, holes? All right, that was in green. All right, so I'm going to go green here on mine, just so it's easier to see. Sometime today. All right, so with this one, remember to find the holes. It's where you have the common factor, right? So what is going to be the hole here? We get x is equal to 2, so that means we have a hole at x equals 2, but that means I have to get the ordered pair. So I got 2 something is going to be my hole. Well, plug it into now your simplified expression. So we just got to go 2 times 2 plus 3 over 2 plus 2. So what did you guys get with that? 7 over, yep, 7/4. So 1 3/4, kind of easy to graph if you think of it as 1 3/4. 7/4, just under 2 is another way of thinking about that. So where's that hole going to be at? Well, let's make sure we put it in there. So that's going to be at 2's at 2, and then we're just under it, but right there, that would be your hole. You have a question? Are you guys good? Yes, but I don't dig in it. Okay, sorry. Legitimate hole, sorry. Can't help. It's Wednesday block. Bad humor is a great way to start the day. All right. So, with this one, my friends, sadness, I know. Moving on. Just moving on. All right, what are your zeros for this one? All right, I think we did holes next. What are the zeros? We did that in what color? Gray. All right. So, remember to find the zero. What do we got to do first? That's when your numerator without the common factor is equal to 0. So if you're finding 0, you're going to go 2x plus 3 is equal to 0. What's x going to equal? Does that mean negative 3 halves? So negative 3 halves. So that means my ordered pair would be at negative 3 and a half. So it's negative 1 and a half right here. So we know our graph is going to go through there. So far, we're most of the way through. Most of the way through. Now we got to make sure, though. This not work today. Oh, love it. All right, horizontal asymptotes. How do we find the horizontal asymptote again? Where do we look? The degrees. I look at these two right here. What's so special about their degrees? They're the same. So which scenario is that? If they're the same, how do I find it? It's the ratio, right? So isn't that really 2 over 1? So my horizontal asymptote is when I have y is equal to 2 over 1. So that's really just 2, right? You say y equals 2. So then I'm going to have it right here. I'm going to put that in there. Now, looking at this graph, can you guys probably guess what would be over here in that lower, I wouldn't say like the lower quadrant, but to the kind of the right of my two asymptotes intersecting? Could you probably guess what that's going to look like? Doesn't it almost look like I'm doing like the natural log or something like that, or like our inverse function? I heard someone say inverse function. Awesome. So isn't it going to look something like this? Make sure if I can do it without totally messing that up, which I did. Isn't it going to be looking something like that? Because I have my asymptotes. So I have part of it, but here's the deal. Whatever happened to the left side of that function? Like right now, those are very easy to see. But notice there's something addition on there. What was the bottom of this page over here? What does it say? Other what? You're going to want to pick another point. And you want to pick it so you know it's on the other side of your vertical asymptotes. When I look at this, I'm going to probably pick negative 3. So I want to find the ordered pair negative 3. Whatever. Now here's the way you could do this. You can literally plug it back into the very original function, or you can plug it back in just as you have here in the simplified one where you've taken out your common factors. And to me, that's just easier numbers, so that's the one I'm going to do. So I'm literally going to go here. So you have your 2x plus 3 over your x plus 2. But to find that, I'm going to plug in negative 3. So I got negative 3 plus 2. So I ended up getting, what's that? A negative 6 plus 3 is a negative 3 over a negative 1, which gives you what? 3? Negative divided by negative, I hope is positive, right? So my ordered pair, my other point is at negative 3, 3, which means I'm up here. Can you guess, probably without being perfect, what it would look like going through that point? Wouldn't it look like almost like that L shape, that curvy L shape that we have? It very much doesn't look like an inverse function a little bit when you're working with it. So you really have, that should be approaching, this is where my redrawing should look something like that. Now, how can you check if you did it somewhat right? You have a new calculator? Get it out. Let's see if we did it right. Yes. Okay, so if this is when we have the three scenarios. So I'm looking at the leading coefficient of both the denominator and numerator, and they're the same. Okay, so then it's, if they're the same, I'm going to have a ratio. So y equals some number. The ratio is found literally by putting the two numbers over each other, like the 2 over 1. So that's where the 2 came from. So it's just what the leading coefficients are going to be. That's where it comes from. No, that's a good thing to ask. All right, I'm going to see if I can get this on my calculator here. They're all going to my room right now to get calculators. All right, I would like this. Smart you here, thank you. All right, am I in? I gotta make sure after doing that ACT review that I'm in real number mode. All right, go y equals, clear this off. Plug in the original function. Just put in the very first one here when you're doing it. So I'm gonna have alpha y equals, I'm gonna go 2x squared minus x minus 6. Oops, I didn't do a minus 6. If you graph, either use Zoom 4 or Zoom 6. I don't care which one you choose to use on that one. Let's see, Zoom 4. It looks pretty good. This is better view than I've seen on the other calculators. Do you see how there is a slight hole there? Go in and notice if I did Zoom 6, how it would be different. You guys stay there. Do you see the hole now? No. So notice it's really how close you can get into this or out away from it if the hole is going to actually show up. So the cool thing is you could see it on Zoom 4. You could see the hole, but you can't on Zoom 6. So just know you're not going to trust when you look at your screen where the hole is going to be. But doesn't it look pretty accurate from what we have otherwise, though? A 0, negative 1/2. Now, here's how you can tell if you have a hole correctly, though. Go second, table. At 2, we said we had a hole at 2 and 7/4. Do you notice it goes down 2, and what do you see in the y1? Here. I don't know why my y2, I must have the volume of intersection going in. Are you guys with me on that? You can literally see the error. Also, you're going to see an error at your other intercepts and stuff too. So notice when I had a negative 2 is it negative 2 or vertical asymptote on that one? Is that right? Yeah, a vertical asymptote is negative 2. Look at your vertical asymptote. What does it say for your y as well? Here. So know you're doing something right. No, you're doing something right on those. So that's an easy way of checking yourselves. Easy way of checking yourselves. All right, do you want to do one more together before you try on your own, or do you guys want to try on your own and then we just go back and forth? How do you guys want to do it? Try on your own? All right, so this is what I want for you guys to do. Down below are all the graphs. So basically, this is if we were to assign homework, we'd have given you, and I said, these 6 problems, all right? We would have given those for you to do, is what we would have done. So I want you to try this. And right away, we try to throw sumpers at you. So just know that. We want you to think it through. So I'm going to hit pause on the video, do this for the next 5 minutes or so, and then we'll do it together as a group. Actually, we can do more than 5 minutes, but however long. So those of you in 3rd period, this is what we're doing. So chill and actually do the problem. All right, guys. So let's help the people who are in Mr. Smith's 3rd period class get this one right. Now, when you're doing this, you got to completely what? You want to completely factor. So when you're looking at the numerator is already factored, but the denominator is not. So I have x plus times the quantity 2 plus x in the numerator. But then if I take an x out, I got a 2 minus x. Correct? So then when I'm looking for, when you think about this, my vertical asymptote, that's when my denominator is equal to 0. So my denominator is equal to 0 at x equals 0, and it's at x equals what? This is where it's the key one. I have x equals 0, and I have x equals, when the denominator is equal to 0. This is where a lot of people might mess up signs. You have 2 minus x is equal to 0. What are you going to get? X is equal to positive 2. Now, what's so special about that x equals 0? That's going to end up being a what? Whole, because that's a common factor in the numerator and denominator. That's going to end up being a whole. So we're going to talk about that in a moment. But right now, I'm going to have my vertical asymptote first. Asymptotes are lines. The correct way of writing that down is you have a line. So that's at x equals 2. So you're going to sit there and put your line in. So draw it in right away. Your wholes, we got to do that next. Because remember, we do that right afterwards. The wholes are where we have our common factors. So we really have a whole at when my x is at 0. So I got my 0 here. I got to plug it in. I'm going to plug it in to my simplified fraction there. So you end up getting 2 plus 0 over 2 minus 0, which equals what? 1. So my whole is at 0, 1. So here's 0, open circle at 1. I also now need to find my zeros. The zeros are going to be, I'm going to do this, change it to gray so I keep my theme going here. Let's see if this will work. Love technology. It hates me. All right. All right. So when are we going to get our zeros? That's when the numerator is equal to 0. So that's when I take the top here. I get 2 plus x is equal to 0. Isn't x going to equal negative 2? So really your 0 is an ordered pair. I want everyone to remember that. It's the ordered pair at negative 2, 0. It's just that we get sloppy and we're like, we know that's where our x is equal to. So we got negative 2, 0. There's our point. So far, you guys with me on that? So you can even write as an ordered pair if you want. Doesn't matter. It's up to you. I'm kind of flexible on this one. Probably too slack on it. Then you have to find your horizontal asymptote. Now this where it's a little bit tricky. Do they have the same degree? Yeah, they have the same degree. This is where it would have been really nice if they hadn't started factoring it for you. It would have been better if they left it like this. F of x is equal to 2x plus x squared over, what do we got here? 2x minus x squared. Because what's the degree of both of those? The numerator and denominator, they have the same what? They have the same degree. So when they have the same degree, I look at that and say, okay, same degree, I'm going to have a ratio this time. So it's going to be y equals some ratio. It's leading coefficients. What's 1 over negative 1? Negative 1. So that's just y equals negative 1. So I go over here, and there is going to be my horizontal asymptote. Now, what's the other thing we need? We want another point, because right now, but most of you are probably right on, and you're like, I know how I'm going to draw this side. It looks like we're going like this, correct? Approaching our two asymptotes. So that one is fairly easy to see, but I need to find, like, what happens? What's happening on the right side of my vertical asymptote? Well, that's when you pick a number. Like, which number would you logically pick? There's probably 2 that you pick. 3 or what? Would you like pick 3 or 4? Because if my vertical asymptote's at 2, I'm going to pick one of these 2 and plug and chug it in. So I'm like, okay, I'm going to pick 3. I like smaller numbers. You can go back to your simplified function like we have there when we've simplified our x's out, and you can just go here. You go 2 plus 3 over 2 minus 3. Did you guys end up getting like a negative 5 for that? So my other point is 3, negative 5. So go 3, negative 5 is going to be down here. So probably, isn't this what it's going to look like? Close enough? All right. Go ahead and let's keep working on the other ones. Sound like a plan? I think we'll get the rest of these. We'll start cranking out pretty fast. There's one type of example I did not give you. I'm pretty sure I did not do no horizontal asymptote example. So if we have time, I'll try to put that in there. All right, let's keep working on these, and we'll just keep going back and forth. Sound good? All right. Actually, I think I went 3-2. I went my point off here. All right. Did you guys work? At least this is the ones I chose to work with. On number 16, on this one, did you get your whole at negative 1, 0, your horizontal asymptote as y equals 1/2? Remember, asymptotes are equations of lines, so you have to have your y equals and your x equals with this. Okay, so they are lines, so you have to have the variables. Our 0 had been at negative 1, 0, but notice the whole and the 0 is the same thing. Is that okay? Because that's where it would cross the x-axis otherwise. So it's okay that you can have holes and zeros that are the same value. And then I just plugged in for my point, was it 3, 3 or 3, 2? Did I do my point wrong here? Hold on. What did you, if I plug 3 in, double check something. Oh, that should be 3 plus 1. Hello, did not work. 3 plus 1 should be 4, 4, 2. Isn't that 2? Is that right? 3, 2? Double check my math. 3, 2, I think that's what would make more sense on there. Okay, that was really rough drawn. Did you guys all get that? How's it going? Some of you are like on the 3rd and 4th one already. Are you feeling good? All right, keep on going. I'll just interrupt when I need to do a quick explanation on this for people to